So till now we discussed two major things: the direction of movement in the cervical, thoracic, and the lumbar. Along with that, we discussed the amount of mobility. So maximum amount of mobility is in the cervical spine, and the least amount of mobility is in the thoracic spine. Okay, so that was a good discussion about the amount of mobility and the direction of movement of the vertebrae in different sections of the vertebral column. Now if we move further, we can see we have a bunch of these ligaments which covers the whole of the spine. So in total we have six major ligaments in the whole spine. Mostly it's the anterior longitudinal ligament, this one. It's the posterior longitudinal ligament, this one. It's the ligamentum flavum, which is quite a famous ligament, most of the people know about it. Then we have the interspinous ligament, supraspinous ligament, and intertransverse ligaments. So mostly these six ligaments we get to see in the vertebral column. All right, so mostly I think they pretty much they're self-explanatory. The anterior longitudinal ligament, let me show you here. We will be discussing all this in a bit, but let's discuss the anterior longitudinal ligament. So the red one, this one, or here we can see this is the anterior longitudinal ligament, which spans all the way through the vertebral column on the anterior, the front section of the vertebral body. So this is the vertebral body, and this is the neural arch or the posterior structures of the vertebra. So on the anterior most part of the vertebral body runs the anterior longitudinal ligament, this one. Then we have the posterior longitudinal ligament, this one, running through the posterior section of the vertebral body. Then we discuss the posterior longitudinal. Then we have the ligamentum flavum going through this. We'll discuss the attachment of the ligamentum flavum, how it goes. Then we have the interspinous. So between each spinous process, we have the interspinous ligament, which is kind of over here. So this is the spinous process of this vertebra, and then this is the another spinous process. So this is a cut section of the vertebrae, and between the spinous process we have the interspinous ligament showed in the green color. And then we have the supraspinous. It just touches the tips of the spinous processes of each vertebrae, hence called as the supraspinous ligament. So we discussed the interspinous and the supraspinous ligament. Okay, now if we talk about the orientation, how these ligaments are there. So we already discussed the anterior ligament and anterior longitudinal ligament. It runs on the front section of the vertebrae. But if we precisely talk about the placement of the anterior longitudinal ligament, so here in this picture we can see, so this is the lower. So here this thing, it depicts the orientation of the anterior longitudinal ligament. So from the sacrum it goes all the way till C2. So from sacrum till C2 like this, it's called as the anterior longitudinal ligament. But as we go above C2 till C1, so we all know this, that C1 and C2, they're called as atlas and axis as well. C2 being called as the axis and C1 being called as the atlas. So it's the nicknames given to these vertebrae. So can we say, and then of course C0 or the occiput or the lower part of the head. So we have the C0, the lower bottom of the head. We have the C1, the axis, and C2, the C1, the atlas, and C2, the axis. So above C2, the anterior longitudinal ligament, it's named as the anterior AA, anterior atlantoaxial, between the atlas and the axis. So between the atlas and the axis, so hence called as the anterior atlantoaxial ligament. So the anterior longitudinal ligament above C2 becomes anterior atlantoaxial, and then above C1 it becomes anterior atlanto-occipital ligament. So anterior atlanto-occipital between C0 and C1, and anterior atlantoaxial between C1 and C2, and below that until sacrum it's called as the anterior longitudinal ligament. Likewise, we have the posterior longitudinal ligament, which runs from again sacrum up to C2. But then above C2, unlike anterior longitudinal ligament, it's not called as the posterior. So posterior AA or posterior AO, but it's called as the tectorial membrane. So the posterior longitudinal ligament from the sacrum up to C2, it's called as the posterior longitudinal ligament running on the backside of the vertebral bodies, and above C2 it's called as the tectorial membrane. It's very, very important to remember these names. Likewise, we have the ligamentum flavum, which we will discuss in a bit, but just to mention, it goes between sacrum and C2. So the ligamentum flavum is just present between sacrum and C2. Anterior longitudinal ligament and posterior, they're also between sacrum and C2, but the anterior longitudinal ligament has its extension called as the anterior AA and anterior AO. The posterior longitudinal ligament has its extension called as the tectorial membrane up above C2. The ligamentum flavum goes just between sacrum and C2. And we have the supraspinous ligament, which runs between just touching the tips of the spinous processes, and which runs between C7 and L4. So the supraspinous ligament doesn't go below the L4 region, and it doesn't cover the cervical part as well. And if we talk about the like over the cervical region, like over the C7, it's called as the ligamentum nuchae. So it's the ligamentum nuchae covering the cervical part or the extension of the supraspinous ligament, but below C7 until L4, it's the supraspinous ligament. Okay, now we left the ligamentum flavum, which we can discuss here. So it says the ligamentum flavum, it connects the lamina to lamina from C2 to sacrum. Okay, so what exactly the lamina is? So as we discussed in the previous videos, we need to go a bit up for that. So in this thing, here we can see this is the spinous process and these are the transverse processes. Now the bridge, so let me change the color. So here the bridge, this one between the transverse process and the spinous process. Likewise, the bridge here between the transverse process and the spinous process, this is called as the lamina. And between each vertebrae, it's the ligamentum flavum which attaches the lamina to the lamina of the vertebra above, and likewise it attaches lamina or to the lamina of the vertebra below. One more thing to mention, just like this bridge, we have another set of bridges. So we can see here, it's this one here, this bridge between the transverse process and the vertebral body. Likewise, this bridge between the transverse process and the vertebral body, that's called as the pedicle. I believe we discussed the pedicle in the last video as well. So the pedicle is the bridge between the transverse process and the vertebral body, and lamina is the bridge between the spinous process and the transverse processes. So the ligamentum flavum, again coming up to the ligamentum flavum, here we can see the ligamentum flavum, it connects the lamina to the lamina of each vertebrae, and remember it goes between C2 to the sacrum. Okay, here we can discuss one more concept. If we talk about, because we know that we have these bunch of muscles as well attached between each vertebrae, and then of course we have these ligaments as well, but both of them, they function a bit in different ways. For example, let's say this is one vertebra and this is another vertebra, and there is a ligament attached between them. Example, let's say if we talk about the intertransverse ligament, which is supposed to be between the transverse processes of the superior vertebra and the inferior vertebra. So the superior transverse process and the inferior transverse process, there is a ligament over there. So if I try to turn or tilt sideways on my left, so the right side intertransverse ligament will be stretched, will become taut, and the left side intertransverse ligament will become lax. And at the same time, if we discuss about the muscles, so let's say there is a muscle between two transverse processes on the right side and transverse processes on the left side. The mechanism how the muscles function is very, very different. It depends on the orientation of the body. Let's say if I'm standing, and again if I try to turn to my left side, the muscles between the transverse processes on the right side will be activated, not the muscles on the left side. Even though I'm turning on my left, but the muscles on the right side, between the transverse processes are going into an eccentric movement because they are lengthening, but at the same time they are under activation, they're under tension. So the muscles on the right side, I'm talking about the muscles between the transverse processes, are active and they are lengthening. Hence there is an eccentric movement happening on in the muscles on the right side of my intertransverse, between the transverse processes. But at the same time, if I go on my side lying position, if I lay on my side, and now if I try to turn, or if I try to curve my body again to the left, but when I'm laying on my side, this time the muscles on the left side between the transverse processes would be active and they would be going into a concentric contraction. Again, it's quite a complex topic to be discussed, and we can discuss this thing in the subsequent videos, but this is just a gist of this I'm giving to you.